All right, so we are continuing with naming branched chain alkanes. So before we start the naming process, let us learn about the branches. Now, what did they do? Normally, when making a branch, you can take an alkane like methane. So a methane looks like this, and you remove the hydrogen. So when you remove the hydrogen, so this one is a methane. When you remove a hydrogen, you form a methyl branch. So this branch is known as methyl. We can also take ethane. So we have ethane here with 2 carbons. Now if we remove this one hydrogen, we end with ethyl branch. So these are the branches that we are going to use when naming branched alkanes. So we are saying we have 2 types of branches we are using, methyl branch and ethyl branch. Actually, there are other types of branches like propyl branch, isopropyl, but we are not going to focus on them in this course. So let's see how we are going to use those branches to name branched alkanes. Let us start with this alkane molecule. Name the following branched alkane. So how do we name it? First, we use rules that help us to name the alkane. So I'll be outlining the rules pertaining to this molecule, and probably I will add more rules when we name the rest of the molecules. So rule number 1. Look for the longest chain. So look for the longest chain on your alkane. Now, how do you know the longest chain? Depends on number of carbon atoms in the chain. That is rule number 1. How do we apply that rule here? But before we look for the longest chain, rule number 2. Start counting from the end where the branch is. That is rule number 2. So here we are looking at this molecule and say which one is our longest chain. So I'll start counting this chain from here. We have carbon number 1, 2, 3, 4, 5, 6, 7. As you can see, my 1 is here close to the branch. So this is one chain. So chain number 1. But there is also another chain. We can start from here. 1, 2, 3, 4, 5, 6, 7. That is chain number 2, which goes this way. So we have 2 chains here. Now, which of the 2 chains is longer? So this is, let me call this chain A. This is chain B. Now, both chains have 7 carbon atoms. So both have 7 carbon atoms. So we can use either chain because they are the same length. So in this case, the best way is to use the chain that is straight, that does not have bends. So probably we are going to use chain A in our naming this molecule. So these are the first two rules. Now, rule number 3. Rule number 3 is you need to locate where the branch is. So locate the branch. You need to give the location of the branch. So in our case here, the location of the branch is at carbon number 2. So then rule 4, name the branch. So in our case, because the branch here, it has 1 carbon atom, the branch is methyl. So let me use these 4 rules to name this molecule. All right, so we are saying so the longest chain has 7 carbon atoms. So we can say this molecule is a heptane. That's what we have. Now, the branch that we have, so this is longest chain, heptane. The branch is a methyl branch because it has a single carbon atom. But this branch, location of the branch is carbon number 2. Now, because of that, if you add branch and location, branch plus location. So the methyl is at carbon number 2. If you add the 2, we say the whole branch and location is called 2-methyl. So it tells us that the branch is methyl, but it is at carbon number 2. Now, so the whole molecule, the molecule name combines the branch and the longest chain. So the molecule name is going to be 2-methyl heptane. So that's the name of the molecule. So 2-methyl, it tells you that 2-methyl heptane, it tells you that the molecule is a heptane but has a methyl at carbon number 2 based on our rules. So this is the name of the molecule. Let's look at another molecule and let's remember the rules. So name this other branched alkane. Now, if you look at this alkane, based on rule 1, we count which one. We look for the chains. The first chain is this one. So we are going to count from which side? So if you look at this side, from the junction, this side, we have 4 carbons. From the junction going this side, we have 3 carbons. So what we are saying, we have to start from this end, because the branch here, this branch is closer to this end because we have 3 carbons including the junction, while this side we have 4 carbons including the junction. So the first thing is to determine which ends are we starting counting from. So we are going to count 1 carbon, 2, 3, 4, 5, 6. So that's the first chain. Let's count the second chain. 1, 2, 3, 4, 5, 6. So both chains have 6 carbon atoms. So this is chain number 2. This is chain number 1, or chain A, chain B. So in this case, because the straight chain without bends is chain A, that's the chain we are going to use. Now, once we know the chain we are using, we need to be able to name or locate the branch. Where is the branch? And also, what is the name of the branch? So our branch is this one. So this branch has 2 carbon atoms. So it is like, this is the branch we are talking about. That's the branch we are talking about. So this branch is an ethyl. But this ethyl is located at carbon 3. Located at carbon 3. The longest chain has 6 carbon. So longest chain has 6 carbon, which means the chain is hexane. So this molecule is a hexane. So I'll say longest chain is a hexane. The branch is an ethyl. Location, it is at carbon number 3. Branch plus location, it is 3-ethyl. Now molecular name, the molecular name is 3-ethyl hexane. So that's how you go about naming the molecule that we have above here. So let me just get rid of all the things and just, so that you look at this molecule and you say, yeah, this molecule is 3-ethyl hexane. It is telling you that the molecule itself is a hexane, but it has an ethyl group, an ethyl branch at carbon number 3. So let's go to look at another molecule. So take note, this is the name of this molecule here. Let's look at this molecule. What is the name of this molecule? So this molecule has several chains, but the chain we are going to look at is chain number 1 is from here to here. Chain number 2 is from here to here. So you can take either chain and name the molecule based on which of the two chains you want to use. The name will just be the same. Now we are going to use the chain that we have there. This is carbon number 1, carbon number 2, carbon number 3. So because it has 3 carbons, this molecule is a propane. This molecule is a propane because it has 3, the longest chain has 3 carbons. Now, it has 2 branches. The first branch is a methyl. Its location is carbon 2. So we can say when you combine these, we can say we have 2 methyl. Branch number 2. Branch 2 is also a methyl. Location also carbon number 2. So that branch is also a 2 methyl. Now you can say, you know what? I want to name this molecule. So combining the branches, combining the 2 branches. So you can call this molecule 2-methyl, 2-methyl as the 2 branches. But you don't want to do that. So what we do to avoid doing that is we just take these 2 and put them together and say the branches are 2 and 2, because both methyls are at carbon number 2. So we say the branches are 2 and 2, 2, 2. And then we put a dash after the second 2. Instead of saying methyl, methyl. So instead of saying methyl, methyl, we don't say that, but we say it is dimethyl because there are 2 of them. So this branch is 2,2-dimethyl. So we use this, but we don't use this. So take note of that. Now the whole molecule is 2,2-dimethyl propane. So that's the name of the whole molecule, 2,2-dimethyl propane. So 2,2-dimethyl propane means we have 1 methyl at carbon number 2, and we also have another methyl at carbon number 2. And because both of them are methyls, we just call them dimethyl to show that we have 2 methyl in there. So if I can get rid of this part and just again to tell you that this molecule here is 2,2-dimethyl propane. Let's name a third molecule or a fourth molecule. Now this molecule is a little complicated, but as usual, first you need to look for the longest chain. So there are several chains here. You can have this chain, that's chain number 1. You can have this chain, that's chain number 2, or you can have this chain from here, that's chain number 3. So you just need to pick which one is the longest. So if I say this is chain 1, A, B, C. If you look at the 3 chains, chain A and chain B have the same number of carbon atoms. So you can take either chain. Chain C has 1, 2, 3, 4, 5, 6 carbons. While chain A has 7 carbons, chain B also has 7 carbons. So we are going to select chain A in this case. Now, using chain A, as usual, we count from where the branch is closest to the end. So I need to start counting from here. This is carbon 1, 2, 3, 4, 5, 6, 7. So this tells me that this is a heptane. So longest chain, it's a heptane. Now what are the branches? It has 2 branches. At carbon number 2, we have a methyl. So branch 1, we have a 2-methyl, which means we have a methyl branch at carbon number 2. So this is branch 1. Now this is branch 2. Branch 2, we have a methyl branch at carbon number 4. So we are going to call it 4. We have an ethyl. So this is a methyl branch. This is an ethyl branch at carbon number 4. So we are going to call it 4-ethyl. Now, how do we name the molecule? Especially that we have 2 branches. We have a methyl and we have an ethyl. So when naming the molecule, use alphabet. So when naming branches, follow alphabetical order, which means you have to start with ethyl before you name methyl. That's what we mean by follow alphabetical order. So in this case, I am going to name the molecule. So the name of this molecule is 4-ethyl, because alphabetically we start with E before we go to M. So it will be 4-ethyl from this branch, then dash 2-methyl, that is coming from this branch, and then heptane. So that's the name of this compound, 4-ethyl 2-methyl heptane. Now if I can get rid of this part so that you know that the molecule we have above here is called 4-methyl or 4-ethyl 2-methylheptane. So that's how we name branched chain alkanes. Now let's go on to talk about another another type of alkanes that we call cycloalkanes. So these types of alkanes are cyclic in nature. So cycloalkanes will lose two hydrogen atoms when they make the cycles. So they will lose 2 hydrogen atoms. So let's look at the formula. For normal alkanes, the formula is CnH2n plus 2. That's the formula for normal alkanes. But for cycloalkanes, the formula is CnH2n, which means they have lost this 2 here. So if you have an alkane with 4 carbon atoms, so you have C4, you are going to have H8. That is cycloalkane. So this is cycloalkane or we call it cyclobutane, C4H8. But normal butane, which is not a cyclo, is C4H10. So this tells you that the cycloalkane loses 2 electrons. The same thing with this one. This has 6 carbon atoms. This molecule has 6 carbon atoms, so it is a cyclohexane. Its formula is C6H12, while normal hexane has the formula C6H14. So you need to take note. If I tell you this is an alkane with C6H12, you need to know that that is a cycloalkane. It's not a normal alkane. If I say this is an alkane with C6H14, you know that this is a normal alkane or normal hexane. So this one is known as cyclobutane because it has 4 carbon atoms. So this is cyclobutane using condensed formula. So this part here is condensed formula. This part is skeletal formula. So it's just the same thing. But both of them are dealing with cyclo. So this is cyclobutane, this is cyclohexane. Now, in terms of naming, you can also name cycloalkanes like we do with normal alkanes. So let's look at this one. This part here, the parent molecule, is a cyclohexane, but it has a branch. The branch is methyl. So the whole molecule is methyl cyclohexane. This one The parent here is cyclopentane. Now the branch here is ethyl. So this molecule is ethyl cyclopentane. So let's look at some more complicated names. This molecule here is a cyclopentane, but it has two branches. This branch is methyl. This branch is also methyl. So you may decide, I will call this one 1 and this one 2. So the whole molecule will be 1 methyl Now, because we have two methyl molecules, we are just going to say we have dimethyl because we have two of them, two methyl branches. But those two methyl branches, one branch is at 1 and the second branch is at 2. So it is 1,2-dimethyl cyclopentane. So that's the name of this molecule. Now, if we go to this molecule, it's the same thing as cyclopentane because the cycle has 5 carbon atoms. But the branch, it has an ethyl branch here and a methyl branch. So as usual, you need to follow alphabet. Follow alphabet. And because of that, 1 will be here. So this is 1, 2, 3. So you take the shortest distance to the second branch. Take the shortest distance to the second branch. So it will be 1, 2, 3. You don't want to say 1, 2, 3, 4. No, that would be a longer distance. You want to take the shortest distance to the second branch. Now, if you want to name this this cycloalkane, it will be 1 ethyl, then 3 methyl cyclopentane. That's how we name this molecule. So just practice on naming branched chain alkanes, naming branched chain cycloalkanes, and also name the cycloalkanes. Thank you.